Want smaller, faster, and just as accurate models? Then knowledge distillation is the key. So let's uncover its secret. What is knowledge distillation? Basically, this knowledge distillation is a technique used in machine learning to transfer the knowledge of large complex model to a smaller, simpler model. And this larger model is often a pre-trained deep neural network that has been trained on a large data set and has learned to make accurate predictions. The goal of knowledge distillation is to distill that knowledge learned by the larger complex model into a smaller, simpler model that can make similar predictions with fewer resources. So imagine you have a team of expert chefs who have spent years perfecting their recipes for a popular dish, and they have developed a deep understanding of the ingredients, cooking techniques, and flavors that will make the dish exceptional. You want to train a new chef who can make the dish just as well, but without the years of experience and expertise. So knowledge distillation can help you do this by distilling the knowledge of expert chefs into a cookbook that the new chef can follow. So in machine learning, this knowledge distillation involves training a smaller model to mimic the behavior of larger, more complex model. And the smaller model is trained to make predictions based on the same inputs as the larger model, and its predictions are compared to the predictions of the larger model. And the goal is to train the smaller model to make similar predictions as the larger model without necessarily replicating the internal structure of the larger model. For example, suppose you have a large pre-trained image classifier that can accurately identify different types of animals in images. So this knowledge distillation can be used to train a smaller, simpler model that can also classify images of animal but with fewer resources. And the larger model would serve as a teacher and the smaller model would be student. So the student model would be trained to mimic the behavior of the teacher model, making similar predictions for the same inputs. And over time, the student model would learn to make accurate predictions based on the knowledge distilled from the teacher model. So to summarize this, we can say that knowledge distillation is a way to transfer the knowledge of large complex model to a smaller, simpler model. And it involves training the smaller model to mimic the behavior of larger model without necessarily replicating that internal structure of the larger model. And the goal is to create a smaller, more efficient model that can make similar predictions as the larger model while using fewer resources. So to better understand this, let's discuss a simple example of knowledge distillation in Python using a synthetic data set. So this example uses Keras, that is a popular deep learning library for Python. So first let's generate a synthetic data set. So in this example, we have a data set with 1000 samples, 10 input features and 3 output classes. And this X array contains the input data and this Y array contains the one hot encoded labels. Next, we will define the teacher and student models. Now the teacher model would be large complex model while the student model will be a simpler model. So in this example, we'll use two fully connected neural networks. So in this teacher model, we use a dense layer with 3 output neurons and a softmax activation function. This model is trained to classify the input data into one of the 3 output classes. And the student model is similar but with fewer neurons in the dense layer. Now we'll train the teacher model on the data set. So after training the teacher model, we will use it to generate predictions for the student model. And this process is called teacher forcing, where the student model is forced to make predictions based on the predictions of the teacher model. So in this step, we use the teacher model to generate predictions for each sample in the data set and use this predicted class labels as input for the student model. And by doing this, we are effectively distilling the knowledge of the teacher model into the student model. So finally, we'll train the student model using the teacher prediction as input. So in this step, the student model is trained to make predictions based on the teacher prediction. And over time, the student model will learn to make similar predictions as the teacher model even though it has a simpler architecture. Thank you.